record. Okay, so I'm going to take you to your module. So this is in day 2. It's the very first thing. It's a PDF. So I'm going to open it up. All right. So right here, this is the graphical methods reading summary. So what that means is this summarizes literally everything you did in the reading and then the homework. So I just want you to notice, and I want you to download this and print it. If at all possible, download this and print it, all right? So right here, we have no relationship. There's no change. You will see this graph eventually, but we'll very quickly leave it behind. Most of the stuff we talk about has some kind of a changing variable, and this simply states that it starts and ends at the same place. So it's a flat, straight line, and that doesn't really show much. Algebraically, y is equal to b. So here we've got our straight line, which is our goal. This allows us to use our y-intercept form right here, our slope-intercept form, and this is our goal if we have any of the following graphs that come after it. You want to try to bring it to this right here. And so as x increases, y increases proportionally. Now these are the 3 that you were exploring with, and so just tell Isaiah to keep trying to log in. Sometimes it takes a couple attempts. I don't know if he's in here yet. I admitted him.
Yeah, I'm in here.
All right, awesome. So Isaiah, you're good to go. So we've got the inverse, the x squared, and the y squared versions here. And I want to remind you of the example I gave you with the ruler. So if you're not looking at my video, go ahead and pull that up and just remind you of the ruler. A one-to-one relationship where both variables pull the data or grow as data equally is going to be a linear graph. And so with that linear graph, if both of them are pulling equally, if you know anything about tug of war, you don't go anywhere and you stay in the middle. All right, and so it's kind of like a tug of war here. And so which one pulls harder is the goal. All right, so if we have an inverse example, so we've got kind of a bend, a bow like that, that simply means that as x increases, y decreases, and y is inversely proportional to x, which means that in order to treat it, you'd have to use the 1 over x. So again, the point of this is so that you can take the data that is going in the wrong direction, the x data that's going in the wrong direction, and then you replace it with 1 over x. If you divide 1 by a small number, it becomes larger. And if you divide 1 by a small number, or excuse me, if you divide 1 by a large number, it becomes smaller. And so the point of doing that is it flips your data around. So it's going to completely flip the trend of the data, and then both graphs go, or both data sets go in the same direction, and hopefully evenly so, and then it's going to straighten out to a linear line. Now with this graph right here, y is proportional to the square of x, so this is called an x squared graph, and what that means is that as the two grow, one of them grows faster. And so in this case, the y component, or the y data set, is going to grow faster, and it's going to pull it toward the axis. All right, so it grows faster, so it grows in that direction faster than it grows to the right. And so because of that, it starts to curve upward. All right, in order to get this curve to go back to a straight line, we have to even the playing field, and that means taking our x values and squaring them and pulling in the x direction equally. And so that's why this is called an x squared graph. And when you're doing your mathematical expression, it's going to be represented as y is equal to mx squared plus b, because you're representing that you had to do something with the data to turn it into a straight line. And the last, but definitely not least, is our y squared graph. So what that means is that as this data set, as the two data sets grow together, one of them is growing faster, and based on what you're seeing, the x is growing faster than the y. So that's why it curves off to the right, because the rightward values grow at a faster rate. So instead of growing together evenly, it grows faster and it pulls that data down. As it pulls that data, it is going to, again, grow with an exponential nature. So in order to correct for that rightward pull, you have to pull upward and to the left, which is toward the y-axis. That means you're going to have to square your y data, and that's going to correct for that curve, and it should end up giving you a straight linear line, and you represent that mathematically by replacing your y variable with y squared equal to mx plus b. All right, so that is the relationships. All right, so when you state the relationship, tell how y depends on x. That's what this right here, y, the square of y is proportional to x. So the second page is just blank, so you don't have to worry about that. This first page would be what I'd print and what I'd keep, because this is a cheat sheet, because it tells you which, so this second part, modification required to linearize the graph. This is what your homework assignment was really getting at. So here was 1 over x, this one was x squared, and this one was y squared. All right, so just be aware of that. Okay, so what we're going to be doing today is we're going to be exploring a pendulum and pendulum motion. And so I'm going to be going through our assignment. So I'm going to go ahead and pull up modules, and I'm going to let you know, I'm going to put you in breakout rooms, and unless you need me, you're going to be working on your own in a lab group until the end of class. And you have one of two options. You either split it into thirds if possible. All right, so you're either going to split that into thirds and then go through and do one of each of the 3 variables you're testing per person, or you're going to try to distribute the work to make it go as fast as possible. You want to collect data today in class. So your data collection portion, I'm going to suggest that you split that up to make it go faster. And then you share your data. So you might want to start a group chat. You might want to start a Google Doc. You are welcome to do these. This is something you get to decide how to do that with, but you can communicate what you're going to do in the chat or in your breakout room. And then you're going to communicate that data so people can copy and paste it. And then the last thing I'm going to do is show you how to graph some data really quickly for Excel, and then copy and paste it. And I'm going to ask, if you know how to do that, you help your graph, or you help your group graph. All right, so you're doing a lab report, and so I'm going to just pull up the assignment, which is right here. So you should probably go ahead and pull it up as well. So right here, you will be conducting an online simulation lab. The purpose of this lab is to illustrate simple harmonic motion, pendulum motion, and mainly to implement key graphing and graph analysis skills. So you will work through the pendulum lab or the lab report on this. So you're going to go ahead and each one of you need to open up that link. So just to show you, it's going to open you up. And let me go back one step. So you're going to open it up right here. You're just going to hit play. Don't hit download. It's going to open it up in your window, and you're going to click intro. All right, so you're going to click on intro, and it's going to bring you to this. Everything's going to be blank, and you're going to be good to go. So download the lab report template, which is in the modules. It's not here, it's in the modules. It says download, and follow the instructions as you go. Fill in all the tables, that should be S, and answer all of the questions. When prompted to graph the data, you will copy your data into a table in Excel. You will create a graph based upon this data set. Make sure to include title and axis labels. So that is an option in Excel. And so you're going to copy the graph into a Word document. That's what you're going to be working on. So just to let you know, the lab report is a Word document. You're just going to go to the next page at the very end where it tells you to graph, and you're going to copy those graphs in there. You're going to have 3 graphs, so you might have to share that graph. So what I would suggest there would be maybe you use Google Sheets, like Google Spreadsheets. So you might want to do it like that instead of Excel if you know how to use that. Or if you're using Excel, you would copy and paste it into a Word document and either email it to your group or possibly share it in a shared drive. So you have a couple different options on how to do that. If you have questions about that, you're welcome to ask. But I'm going to need a graph for each of the 3 data sets so that you can graphically look at them and then determine a conclusion based on what you see. So you can copy the graph into the Word document, or you can use the snipping tool on your computer to ensure a screenshot. So if someone were to, have a shared document on their Google Drive, but for whatever reason you can download it or something, or copy and paste, you could just snip that image and then use snipping tool, and then you just copy and paste. So just to show you, that's down here. So snipping tool looks like this. You just look at it in your search function. You'd hit new, you drag it over whatever you want to snip. It's going to give you a perfect image of that, and you're going to hit this button right here that says copy, and then you'll go into whatever document you want, and you're going to hit paste. So that would be another option. Okay, so the snipping tool can be found by searching on your computer's search function. So that is your job. So you're going to be going through this. You're going to be identifying Three things I want you to notice. So you're going to be messing with the angle with which you release it. You're going to be messing with the length of the string and the mass. And so each one of these is going to be pretty clearly laid out for you in the assignment right here. So you're going to download this file right here. It's going to open in here, but it's not editable here. So you're going to want to click on this download right there. Now I'm going to full screen it. And just to show you, that's exactly what I just showed you. So I'm going to read this first part to really make sure you know what you're measuring. And if you need the link, it's also here. All right. So you're going to click on intro, but it's in that assignment I showed you, and you'll submit in the assignment. So a pendulum is a bob hanging from a string that is made to swing back and forth. In the absence of friction and air resistance, the bob will repeat its motion indefinitely. This does not happen in real life, as you saw with the video we watched at the end of class on Wednesday with the painting. Like, it slowly got smaller and smaller because it ran out of energy, but there's air resistance and friction there. So here, this is a simulation, so we can take all that out. The motion is repetition of a cycle. So the cycle is up and back. So when it returns back to where you started, that's one cycle. So time in seconds taken to complete a cycle is called a period. All right, so the period of the pendulum is the time it takes to complete a cycle, which is there and back again. So in this experiment, we will study the effect of different variables on the period of a frictionless swinging bob. That is, we will try to see how we can change the period. So you're trying to see what affects the period. So you're going to be messing around with certain different qualities, and only one of them is actually going to change the time it takes to complete a full period. All right, so the first thing you're going to do is you're going to set your length to 0.7, set your kilograms to 0.2, set gravity to earth, friction to none, stopwatch on, and speed to normal. So it tells you everything you need to do, and then you're going to displace the mass by 30 degrees, let it swing. The mass moves from one extreme point through the center to the extreme point on the other side, and it actually marks it with little blue tick marks, and then back to the starting part. Watch the repetitive pattern and figure out what you can define as one cycle. There is more than one configuration. So you have two options. I'm going to go ahead and take the guessing out. You can either take one cycle as all the way there and all the way back. That's one cycle. Or you can do multiples of that if you want to make sure it's accurate. So for instance, you might say 2 full cycles. So there, back, and that's one period. But you need to define that and then mention it here. All right, so just mention whatever your cycle is. You're going to click on period trace to see the path that one complete cycle. There are convenient paths to make up a cycle. So you're going to set the mass into the oscillation practice, finding the time taken for 10 oscillations so 10 oscillations is the general thing for a period. So I want you to let it swing 10 times on the stopwatch, and then on that 10th return to so there and back is 1, there and back again 2, there and back 3. So on the 10th return to the start, you're going to stop the stopwatch, and that's your period. All right. Once you're comfortable measuring the oscillations, you're going to find the time it takes for 10 oscillations by changing the angle through which it's displaced. Do this twice for each angle of displacement, and then take the average. So I want you to look at this data table. So the first angle you're going to start with is 30. So you're going to set it to 30 degrees. That's a very easy thing to do. And you're going to let it go for 10 oscillations. And on that 10th return, you're going to record the time. You're going to do that one more time just in case you didn't stop it or start it at the right time. It starts itself automatically, but you're going to have to stop the stopwatch as it returns to the 10th return. And then you're going to do that a second time and average it. You know that's adding and dividing by 2. All right. So now I want you to take the average. So once you've taken these two numbers and you've divided it by 2, you divide by 10. I tell you this because that's the number of oscillations you had, and this will tell you the period for one oscillation. So remember to divide by 10, and then you're going to try each of these angles. So one person will be doing angles, and you're going to technically do 1, 2, 3, 4, 5 times 2, 10 different trials, okay? So when you vary the angle through the pendulum, you're changing the amplitude or the height of the wave. And so then you're going to answer questions on that. All right, so angle person would probably answer those questions. Then you're going to come and measure the length. So you're going to do 10 measurements for length, and you're going to change the length, and you're going to record the times, take the average, divide by that average by 10 to get the individual period of one oscillation. And then you're going to answer the question, does the length change the period of the pendulum? And then you're going to vary the mass. And so you're going to do the mass, you're going to do the average, divide by 10, and then answer the question, did it have an effect? So what you're going to see is if this number over here for period changes, then the answer to the question is yes. If you do not see a big change, they will be slightly different because you're human and your error measurement is going to be kind of high. As long as they're not, if you see a trend, that means it affects it. If you see no trend and it's just like roughly the same, then there's no effect. Then you're going to compare data. Then you're going to share your data as you do this. You're going to answer questions 1 through 7. You're going to put this right here using the data, plot graphs. So 7 is the graph. So when you get to 7, you're going to be plotting graphs. If you finish before your cohorts, your friends, you're going to go ahead and start graphing. This won't take a ton of time. I'm going to kind of come out of this. Again, remind you, you're going to be here. So let me show you. When you set it to 30, it's quite easy right there. So you'd set it to 30, and you'd let it start swinging. All right, so you're going to turn your stopwatch on. From there, 1, 2, 2, 3. And you do that 10 times. And on the 10th time, I'm going to stop it at 5 right there. That is not the most accurate. I might have missed a little bit. That's why you take in multiple data sets. So this is how you adjust length. You're just going to type the number in. This is how you adjust mass. And you just saw how I adjusted angle. So we're going to reset that. And I'm going to let, does anyone have a question on how to graph data from Excel?
How do you get onto Excel?
Do you guys have Excel on? You should be able to search down at the bottom left. You should be able to search Excel. It's EXCEL.
Oh, okay, okay, I got it.
All right, so you're going to pull up Excel. Where'd Excel go? Here we go. Let me try this. Share. All right, so we got Excel. You're going to, no, I don't want my resume. We're just going to go for blank document. You're going to take your chart. You're going to put it in there. You're then going to say insert. So you can insert a table, type in the table, add your labels, and then you are going to eventually, you're going to say, you're going to be able to graph right in here. So these are your options for, you should be able to graph once you've typed data in there. All right. So if you have any questions, let me know. All right. But I'm going to let you guys go ahead and start working on this. So you can also try to use sheets if you'd like, but probably not going to need to. I'm going to go ahead and pause the